We have just talked about kinetic friction. Now we're going to talk about static friction. Static friction works in some ways very much like kinetic friction. I'm going to start out with a formula and then we're going to get into this and look at some of the differences. So a static friction force, we are going to say, is less than or equal to mu static times the normal force. And if you remember, the kinetic friction force was equal to mu kinetic times the normal force. So we've got some big changes. From static to kinetic, or from kinetic to static, that's a change, right? Kinetic friction worked when we had objects that are moving. Static friction is going to work when we have objects that are not moving. We went from a coefficient of kinetic friction to a coefficient of static friction, and they work the same way, but a coefficient of static friction is usually bigger than a coefficient of kinetic friction. I say usually. I have never come across a case where it's the opposite. I could not mathematically prove to you that it has to be this way, so I don't want to quite commit to always, but when I say usually, I mean 100% of the times that I have experienced. The other big difference is this less than or equal to sign. Here's how that works. If I have a box like this, and I have a coefficient of static friction of, let's say, 0.5, we're going to give this box a mass of 100 kilograms. So it has a downward force of mg, which is 1,000 newtons. It has an upward force of n, which is going to be 1,000 newtons, because these have to be canceling, otherwise we are sinking into or floating off of our ramp, neither of which makes sense. Now if I don't do anything to this, I get no static friction. If I do nothing to this, and if I just said equals mu static times normal force, well, mu static times the normal force, let's just get that out of the way, half times 1,000, that's 500 newtons. I'm going to put a label on this in just a moment. So 500 newtons is my maximum value for that static friction force. I will even write that, F static max. That's if I take the less than or equal to sign and make it into just the equals part. And that's my maximum static friction force. If I push on this block with no force at all, I just leave it sitting here, I can't really have a static friction force because, well, that would mean the block would start moving on its own. If I stand over here and I push with, let's say, 200 newtons to the right, I have not yet hit that maximum static friction force. So what I will get is 200 newtons of pushback in static friction. If I increase my push to 300 newtons, friction says, game on, I will match you for 300 newtons. If I increase my force to 500 newtons, friction says, alright, I will play your game, I can go up to 500 newtons. Here's where we get different. If I increase my force to 501 newtons, I am above my static friction max. I have overcome my maximum resistive force. Static friction says, I can't keep up with that. That's too much force for me. This thing is going to start moving. As soon as it starts moving, I am not static anymore. I now have 0 static friction force because I'm not moving, or I'm not static anymore. I am now moving. All of this friction goes away completely. But Now we get a kinetic friction force instead. It's probably going to be less than 500 newtons. Maybe the coefficient of kinetic friction is only 0.2. So my kinetic friction force is going to be 0.2 times 1,000 is 200 newtons. I'm pushing with 501 newtons. And this thing is pushing back with 200 newtons. It's not going to quit until I come to a stop when I am no longer kinetic, and then static friction takes over again. So that's what static friction does that's different from kinetic friction. In some ways you can think of it maybe as kind of being a lazy force. It works only as hard as it needs to, and even then, as soon as it's going to be overpowered, it just quits completely. Or you can just say, you know what, it's doing what it's able to do, right? It opposes the direction of what motion would be there if the static friction were not. Let me show you what I mean by that. Box on a ramp. If there is nothing else going on at all, then my static friction is going to point up this ramp, because on its own this box wants to slide down. If I have my same box on a ramp, and maybe at the top of this ramp I have a pulley, because pulleys are a recent addition, and I have over here a really big mass. Now this block wants to slide up the hill. Now my static friction will point down. That's what's going on. I'm opposing the direction of potential motion. I'm saying if there is no static friction, what's the direction that this whole thing is going to move? Okay, got it? The opposite direction, that's where static friction has to be. And that's it. That's static friction.